We're in Canton, Georgia today, and our company specializes in wireless site construction, upgrades, new builds, co-locations, all over the Southeast. Today we're working on a site, we're upgrading, we're doing some advancements to 4G LTE. We're going to be adding in AWS with radios on the tower. What's going on here is we're doing fiber and power up the tower to basically put our radios from the shelter right up behind the antenna, so we have minimal loss and nice, fast speed and communication right to the antenna. The majority of the sites are being built this way with radio integrated antennas on the tower with fiber and power going directly to the antenna from the BTS inside the shelter. All major carriers in the United States are leaning towards fiber and radios on the tower.
Sometimes we have pressures from the client to turn a site up by the end of the month, or maybe a certain event's going on, so we have to have a site completed. A lot of added pressure in the back office that from the client or from just a landlord or something that the crews don't see, and a lot of times they don't know why you might be pushing them, but you deal with that every day. So
we'll first survey the site. We'll come out here and figure out what type of cable lengths we need. We'll create a bill of materials. Materials will be ordered. We receive them in our warehouse. We'll pre-test all our fiber, pre-test all our antennas, send them out to the field with our techs. They'll install the equipment on the tower. We'll retest everything in the field to make sure it wasn't damaged upon installation. Once that's complete, we process all our closeout photos and all our data and put it in a package and submit to our customer for billing.
We probably built a little over 400 sites last year. Some sites could take 3 to 4 days. A site like this generally takes 1 to 2 days. Some other sites, maybe a greenfield, may take a month. From start to finish, from breaking ground to getting the last antenna tested. Before we
test our sites, we'll scope each fiber connector. We want to make sure every fiber connector is up to standard. And after our connectors are good, we'll recap them, install them. We'll connect all our jumpers, make sure everything's clean, and then we'll get into OTDR testing. And what we do on these sites is we perform loopback testing, and each antenna will have 2 pair of fiber. So we're doing loopback testing on each pair of fiber, making sure everything meets spec, plug everything in when we're done, passing result. Then we'll usually have some spare fibers. We test those as well for future applications to make sure there's no damaged fiber left on this tower. So with these spare fibers, it easily allows you to migrate off existing coax sites and antennas to radio heads. So basically, we're building a 4G LTE advanced. We're putting everything on radio heads and fiber. Once everything is working correctly on that network, then we'll start migrating the other stuff off of coax onto radio heads and fiber as well, with the future spare fibers that are available for us. The most important part of fiber testing is cleaning your fibers. If you have an exposed fiber, before you plug it in or hook something up to it, we're cleaning it. We spend the most time on cleaning fiber connectors, making sure everything is spotless. A clean fiber connection is the key part to this installation. Individual scope plots of each connector are required by the customers. A site like this will have 96 scopes and 12 OTDR results. So we've been using OTDR for about 2.5 years. Before that, it was just doing a power test with an ODM, just a power test on each fiber strand. We weren't scoping the connector. We were just checking to make sure power and light would pass through that fiber strand. Now it's a little bit more intense. We check, connector loss is very important. Optical return loss is very important. Reflectance is important. And overall loss on that link is extremely important as well. Introducing these additional steps into testing helps us validate proper installation. We're not leaving connectors unplugged. We're not installing dirty fibers. By doing our OTDR tests, we're able to tell that we're cleaning our fiber correctly.
Most carriers want their closeout documents in within 48 hours of the site being complete, so they can get an integration crew out there immediately. There's a lot of added pressure if the site don't come up on time, or say maybe something's not working quite right, getting someone back out to make sure, see what's wrong. It could be equipment failure. It could be maybe something needs to, retested. Could be in the weather. Maybe some water got into something. SFP is a good one that goes, SFP wasn't seated correctly, or maybe, it's not working correctly and just needed replaced.
The main thing on our truck rolls will be a connector not plugged in all the way. The guys are used to working with large coax, inch and 5/8 diameter coax. It's a heavy duty coax. You can move it around a lot. The connectors, you can bang them around, you're gonna be okay. Get into the fiber connector, it's more delicate. Plugging them in together in the coupler, sometimes if the guys won't hear a click, especially when you're on the tower and it's a windy day, you're not always going to hear that click. So what we're trying to do is just verify and pull back on our connectors to make sure everything's seated. The SFPs on the tower into the antenna will not be fully seated, or the fiber is not fully seated into the SFP is our #1 problem.
One thing we've always wanted to do is we've been asking ever since the Air 21s or the RUs came out on the top of the tower, how we could test them and make sure they were working before we left. That's always been a big hang-up for us. The gear is is proprietary. We're not allowed to log into it, so we can only power it up and see all the lights come on. We do all our testing on the fiber, but if we actually had a device that actually passed data, we know the SFP all the way to the ground is good. That's always been a huge hang-up, and we've been arguing that since we started this project.
So what would help us is a SIP revalidation test, which we experienced today. What that entails is we check our SFP top to bottom and our fiber link, and we're able to confirm that that link and that SFP is working. That would help us ensure that our install is completed correctly.
I think the SIP testing we're doing today would be one great tool, just for us to have to use, even if it's not required by the client. I think it's a good in-house tool. I'd say 8 out of 10 return trips is for the antenna. This needs to be reseated up top. SFP is not seated correctly or is bad and needed changed. So if we knew that was working, even if we did something wrong on the bottom, you can fix it you don't have to have a climb, just have a guy drive out there. So I think it's a great tool.
The SIP revalidation test is not required yet, but it will be soon, and we're looking forward to it.